Good morning, students. Today's topic in the chapter of organic chemistry is alcohols. This is very important topic, so concentrate yourself. We are going to start now. The general formula of an alcohol is CnH2n plus 1 OH, where N is equal to 1, 2, 3, 4, and up to so on. Alcohols are a family of organic compounds containing carbon, hydrogen, and oxygen. Their functional group is OH. Alcohols are named by replacing the E in the name of the corresponding alkane with OL. Table below shows the first four members of the alcohol family. Name is methanol. So at the end, E is replaced with OL. Methane is replaced. E is replaced with OL. So methane, methanol. Ethane, ethanol. Propane, propanol, and up to so on. Molecular formula is CH3OH. Structural formula is C. Single bond will be made with 3H and one will be OH. This is the functional group. So one H is replaced with OH. That's why this is now methanol. Likewise, ethanol. Molecular formula is C2H5OH. Likewise, in the ethane, one H is replaced with OH. Propanol. Molecular formula is C3H7OH. Again, in the structural formula of the propane, last H is replaced with OH. Likewise, butanol. Molecular formula is C4H9OH. Here is the structural formula, and if you can see, H is replaced with OH, and this is now butanol. Last E is replaced with OL. So butane, butanol. Propanol has two isomers. First is propane 1-ol and second is propane 2-ol. The method to read the formula is, we will see at which end the functional group OH is near. If you can see in this structure, OH is near to the right side. So first we will count the carbon atoms. 1, 2, 3. 3 stand for propane. And OH is attaching with the first carbon atom. That's why propane 1-ol. Likewise, in this structure, we will choose the side from where the OH is near. OH is exactly in the middle, so we can choose the either side, the left or the right. For example, if we move from the right, first we will count the carbon atoms. 1, 2, 3. So 3 stand for propane. And now OH is attached to the second carbon atom. So propane 2 and OH stand for ol. So propane 2-ol is the formula of this structure. Isomers have the same formula, but their atoms are arranged differently. Notice the way the name of each isomer tells you where the OH group is on the carbon chain. The numbering always starts at the end nearest the OH group. These isomers of the propanol are both alcohols, but their physical properties are different. Look at the table. Propane 1-ol, its boiling point is 97.5. Propane 2-ol, its boiling point is 82.5. Look at the physical properties are different of two isomers of the propanol. Formation of the ethanol. Ethanol is obtained by number one method is fermentation. Second method is catalytic addition of the steam to ethene. This is industrial manufacture. Fermentation uses an enzyme in yeast to break down the glucose in sugar or starch into ethanol and carbon dioxide. Here is the equation. Fermentation is catalyzed by the enzymes present in yeast. This reaction requires a temperature of about 18 to 20 degrees C. Equation is here. C6H12O6 in aqueous form. When it is fermented, it is converted into alcohol and carbon dioxide. This is ethanol. About a week later, the fermented mixture is filtered and the alcohol is extracted by fractional distillation. The fermentation process must be carried out in an oxygen-free environment to ensure that oxidation to acids does not take place. Fermentation is usually carried out in the home in a flask called demijohn or in the laboratory in a fermentation apparatus. Here is the laboratory process. Here is the home process. This flask is called demijohn flask. In this, yeast and sugar solution is here. This is airlock and sterilization solution is here. This is laboratory apparatus. Lime water is here and yeast and sugar solution is here. The airlock, when filled with water or sterilizing solution, allows the bubbles of the carbon dioxide to escape but does not allow the air to get in. So this is the function of this sterilizing solution. This allows the carbon dioxide bubbles to escape but does not allow the air to come in. Different kinds of the sugars can be fermented to produce different alcoholic drinks. Beers and wines are produced by natural fermentation, and their strength or proof is up to 20% alcohol. Above that concentration, the yeast is killed off. In order to make stronger drinks like spirits and liqueurs, the alcohol therefore needs to be concentrated. This is done by fractional distillation. An exam tip is for you students. The enzymes in the yeast used in fermentation are used as biological catalyst to speed up the chemical reaction. Similarly, phosphoric acid, a chemical catalyst, is used in the addition of the steam to ethene. Industrial manufacture. Addition of steam to ethene at high temperature and pressure produces ethanol. If steam and ethene are bubbled under high pressure through a phosphoric acid catalyst at a temperature of 300 degrees C, conversion to ethanol occurs. Here is the equation of the process. Here is the ethene. This is steam, and it is converted into ethanol. Here is the structural formula. This is an addition reaction. Which method to use? So sometimes condition depends. Which method will be used? Making ethanol from ethene relies on crude oil splice. As you know, crude oil is a fossil fuel that is running out. However, while splice lasts, we make our lower grade ethanol from ethene. The process can be run continuously. Although the reaction is reversible, unreacted ethane is recycled into the reaction vessel. Fermentation is always used to make the ethanol in an alcoholic drink. In countries like Brazil, with no natural oil supplies of their own, ethanol is manufactured on a large scale by fermentation. They have a climate that is ideal for growing sugarcane. So although the fermentation process is a slow reaction, it is the cheapest way for them to make ethanol used as a fuel. The ethanol has to be made in batches and left to ferment. The ethanol is distilled off, then used to run Brazilian cars. This helps preserve fossil fuel supplies as petrol and ethane come from crude oil. It also reduces carbon dioxide released into the atmosphere. So this is double advantage. They not only save their fuels, but also the environment is preserved. Ethanol does not give off carbon dioxide when it burns. But the sugarcane removes CO2 gas as it grows. So it is triple advantage. Fuel is saved in the sense of the fossil fuels. At the same time, when ethanol is burnt in the cars as a fuel, carbon dioxide is not produced. And third advantage is when they grow sugarcane in their country, sugarcane absorb carbon dioxide from the environment. So this is triple advantage. Cars in Brazil can be adapted to run on ethanol on a mixture of petrol and ethanol called gasohol. So they produce cars in a manner that uses a mixture of the petrol and ethanol, which is called gasohol. Reactions of the alcohols. Alcohols undergo three important reactions. These are number one, combustion, number two, oxidation, and number three, esterification. And now we will read them in detail. Combustion of alcohols. Similar to alkanes and alkenes, alcohols undergo combustion reaction with oxygen. The complete reaction of the alcohols produce carbon dioxide and water, while the incomplete reaction produce carbon monoxide and or carbon soot. Alcohol burns in oxygen to give carbon dioxide and water in a highly exothermic reaction. Ethanol is therefore sometimes used as a fuel, for example, in high-performance cars and rockets. Combustion of ethanol is shown below. So this is the combustion reaction of ethanol. Ethanol is burnt with oxygen to form carbon dioxide and water. This oxygen is in plentiful supply because carbon dioxide and water is produced. Otherwise, carbon soot will be produced and carbon monoxide will be produced. Oxidation of the alcohols. This is the second reaction of the ethanols. If left exposed to the air, ethanol turns sour. This is common with wines and beers which are opened but not drunk. So when beers and wines are opened but not drunk, it means left in the atmosphere. They will turn sour after some time. The explanation is that the ethanol has been oxidized by the air to ethanoic acid, which is more commonly called vinegar. Alcohols are oxidized to carboxylic acids. In this oxidation reaction, the alcohol molecules loses 2 hydrogen atoms and gain 1 oxygen atom. Ethanol is oxidized to ethanoic acid. And here is the reaction. In this reaction, ethanol will lose 2 hydrogen atoms, for example this one and this one, and will gain 1 oxygen atom. From here, that will be attached to this. So look at the structure. This edge, this edge, this edge, this edge, and carbon will remain as it is. This oxygen will remain as it is. These 2 hydrogen atoms will be lost and 1 oxygen atoms will be attached here. So this is carboxylic acid. This oxidation is carried out by using atmospheric oxygen or acidified potassium dichromate. During oxidation, acidified potassium dichromate changes color from orange to green. Our third method is purple acidified potassium manganate, which is decolorized. So oxidation is carried out by using these 3 methods. The oxidation agent acidified potassium dichromate changes color from orange to green when warmed with ethanol. This color change has been used in the breathalyzer test to see if drivers have been drinking. Figure below, before orange and after green. So this was the method used in old times. But this method is more advanced. More recently, alcometers have been used instead to measure the blood alcohol concentration. This is called BAC. This is alcometer which is used to check either the driver is drunk or not. The third reaction of the ethanol is esterification. Alcohol reacts with acid to form a sweet, fruity smelling compound called ester. Here is the reaction. Alcohol plus carboxylic acid forms ester plus water. Now we are going to read some uses of the ethanol. As a solvent, it is used in the tincture of iodine and French polish. It is contained in methylated spirits, surgical spirits, aftershaves, and UD clone. As a fuel, it is used sometimes instead of the petrol in cars or for outdoor uses like camping. As a constituent in wine and beer. Ethanol is also used as a flavoring. Ethanol is used in aerosols. And ethanol is used as an anti-freezing agent. So these are some uses of the ethanol. Sometimes 2 or 3 marks question always come in the paper. Requirement is give some uses of the ethanol. So this is important. Here are some uses which is given in picture. Ethanol is used in solvents, in glues, as a fuel, in cosmetics, in beers, wine, spirits, etc. So this is a figure of the uses of the ethanol. Here is a question. The apparatus shown was set up to prepare ethanoic acid from ethanol. Here is ethanol and acidified potassium dichromate. It is heated. Here is cold water in. Here is water out. Here is the condenser. Question is, what was the purpose of the condenser? The answer is D, to stop ethanol vapors escaping. With the condenser, the hot vapor of the ethanol is condensed and flow back into the container. Here is an exam tip for you students. The acidified potassium dichromate will turn from orange to green, and this indicates that the reaction is complete and that the acid is formed. Here is another question. What is produced when ethanol is boiled with an excess of the acidified potassium dichromate? Answer is B, ethanoic acid. Acidified potassium dichromate will oxidize ethanol into ethanoic acid. In this oxidation process, ethanol will lose 2 hydrogen atoms and gain 1 oxygen atom. Water is also formed. So students, this was the lecture for today. This is very important lecture. Read it again very carefully and make your notes. Thank you so much.